In this video, we're gonna let's first label these ones: the x-axis, the y-axis. So this is y f of x. Okay. In this video, we're gonna try to graph g of x defined as 1 over f of x. So we're gonna work something simple, and from this we're gonna learn a lot. So we're gonna graph all the other ones. Okay, there are more techniques that we're gonna learn along the way, but with this one, if we do this one, we're gonna get a lot of information. The first thing to note is that if we have a positive, then 1 over a is also gonna be positive. Okay, so 3 is positive, 1 over 3 is positive. If a is negative, 1 over a is negative. Okay, note here that the domain of our function here, so this is our f of x. This one here, it's like line. So this one, the domain of f is R. It's defined everywhere. As we can see, every value on the x-axis has a value on the y-axis. Okay, so the domain is R. The other thing that we need to note is if we call this number here C, so this is C. What's f of C? What's its value? 0. What's 1 over f of c? So this is an issue. So here we divide by 0. Okay, so here we start to see that we are looking for g of x, especially g of c. Okay, because here we see that when we do 1 over f of c, we're gonna do 1 over 0. Okay, so therefore here we can divide by 0, because when f reaches c, okay, there is no, it's not defined, okay, because it's a 0 here. Okay, so therefore we're gonna take this one as an asymptote. Okay, so here, so let's call it x equals c. So this is an asymptote for our function here. Note here, what's this limit as x goes to minus infinity? It's plus infinity. What's this limit as x goes to plus infinity? It's minus infinity. Okay, here we're going to use this fact, a bigger than 0 and 1 over a is bigger than 0. Here note that on this y-axis here, all these values are positive. Okay, all these values, okay, are positive. Therefore, when we flip them, okay, we're going to use this fact, we're still going to have positive values. Okay, note that in this case, our function is positive decreasing. So when we flip them, it's going to be positive increasing. Okay, how does it increase and when it's going to stop? Okay, so here note this, when we flip, we're going to have here, when we are close to minus infinity, we're going to have 1 over positive infinity. So we're going to have something closer to 0. So 1 over bigger numbers. So it's going to be close to 0 because positive values. So our function will be increasing. It's going to be increasing. And we don't know here, it's going to hit the y-axis at this point. If this point is 1, so it's going to be 1 over 1, which is 1. If it is bigger than 1, so if this one is bigger than 1, then that means something that's bigger than 1 positive, when you flip it, it's going to be less than 1. So depending on this value here, it's bigger than 1 or smaller than 1, we don't know. If it is 1, the graph of g of x will cross this one here at this point here. Because if this is 1, it's going to be 1. If it is bigger than 1, so we're going to cross from here. If it's less than 1, we're going to cross from here. We assume that's going to be less than 1. Note here that these values, as we get closer and closer to c from the left, so these values are positive, but they are small. When we flip them, so 1 over small positive values, we're going to get bigger and bigger here. That's what happens here. The same thing here. So here, we cross C. Okay, here we have negative small values. So 1 over negative small values, it's going to be negative, big negative. Okay, so And once we go to plus infinity, we're going to have 1 over negative small values, negative big values. So we're going to have negative small values. That means here. So here. Okay? Here, negative small values. When we flip them, we're going to get negative big values. Here, negative big values here. When we flip them, negative small values. Okay, remember that. So this is how we graph the function. Okay, so here we use these facts here. Okay, remember this. Okay, and I think that's all we have to do. Except, okay, we treated this case bigger than 1, less than 1. I don't know what else can we do. Okay, that's it for now. Okay, the domain. Okay, I forgot the domain of G. The domain of G is R minus C. Okay, it's defined everywhere except where 1 over f is 0. Okay, so it's this point here where we have the f is 0 because we don't want to divide by f. Okay, and it's also can be written as it's the set of x such f of x is different from 0, and x is different from 0 when x is different from c. So this is the x's in R such that x is different from c, and this is R minus c. Okay, and I think that's all we have to do. Thank you very much.